By the end of this video, you'll easily be able to chop up these log equations, and in about 30 seconds, here's how this video is going to get you there. We're going to start off with a pretty quick log equation, but these are quickly going to get harder and harder as we go. We're going to start seeing some new things like what happens when we get a natural log in our equation, and then problems 5 and 6 especially are going to have a lot more work. And after we go through all of that, I'm going to give you a problem to try and answer in the comments. And by that point, you should be able to chop this log up into some firewood and make some s'mores with it. And if you're looking for the notes for this video, and when I say that, I mean printable notes. I have printable notes for this video, and if you're looking for those, they're linked right in the description. Also in the description, I have an extra video where you and I will go through and solve 12 more log equations. So if you're looking for some more practice, especially if you have a quiz or a test coming up on this kind of stuff, then I highly recommend you check out that extra video in the description. So starting with this first problem, we have the log of 4x minus 5 is equal to the log of 2x minus 1. So how are we going to solve a log equation like this? Well, this is honestly the nicest kind of log equation because the only way for these two logs to be equal is if their arguments are equal. If 4x minus 5 equals 2x minus 1, and you'll notice I use the word arguments there. The arguments of the logs are the things that you're taking the log of. So 4x minus 5 and 2x minus 1 here. Now we know that these things have to be equal because if you have the log of 2, this isn't going to be equal to like the log of 3 or the log of 4 or anything like that. No, they're definitely not equal. The only log that the log of 2 is going to be equal to is the log of 2. So these numbers have to be the same for these two to actually be equal. And so that's how we know that the arguments have to be equal. And so what we can do from here is just solve for x. So let's start by subtracting 2x on both sides. That'll get all my x's to the left-hand side. And then if I'm getting all my x's to the left-hand side, I want to get all my non-x's to the right-hand side. So this negative 5's got to go. And so we can add it on both sides. So on the left, we get 4x minus 2x, that's 2x. On the right, we get negative 1 plus 5, that's 4. And then dividing by 2 on both sides, you can see that x is equal to 2. So that's our first log equation already done. Now moving on to problem 2, we have negative 10 plus log base 3 of x plus 3 is equal to negative 10. And you can see that this problem looks a little bit different than problem 1. We only have one of our terms here that is actually a log. Other terms like this negative 10 and this negative 10, they don't have logs on them. And so this problem is going to solve differently than something like problem 1, where everything that we were dealing with was a log. And these, problem 1 and problem 2, these make up the two main kinds of problem types that you can see with log equations. You can either have everything be a log, in which case what your goal is going to be is to get a log on one side and a log on the other side. Or not all of your terms will be logs, only one of them was a log in this case. And when that happens, what you want to do is you want to isolate your log on one side and get everything else that's not a log to the other side. And so here that means we need to add 10 on both sides to get that 10 to the other side. And doing that, we're going to get a log base 3 of x plus 3 is equal to negative 10 plus 10, which is 0. So we've gotten that negative 10 to the other side now, and so our log is isolated. And from here, we can just evaluate it. So we're going to make this 3 bigger, and we put it here. That 0 comes over, and it is now the power on 3, and the x plus 3 goes to the other side. And if you don't feel 100% comfortable with that whole evaluating logs process, then I did make a whole YouTube video on that. But continuing on here, anything to the 0 power is 1, so 3 to the 0 is 1. And so we get 1 is equal to x plus 3, and subtracting 3 on both sides, we get that x is equal to negative 2. And that is the answer for problem 2. Moving on to problem 3. Now, which kind of problem is this more like? Is this more like problem 1, or is this like problem 2 more? Well, looking at all of our terms here, they are all logs. And so what that means, remember, is we want to get a log on one side and a log on the other side. But we don't want to have 2 logs on one side and 2 logs on the other, so we want to combine these logs. And so how can we do that? Well, looking at the left-hand side, these 2 logs are being added. And so what that means is we can actually combine them into one log. We just have to multiply the arguments. And so we get log base 2 of x plus 2 times x plus 1. Now, it's the same story on the other side. Again, we have two logs that are being added, and so the same rules apply. We combine them into one log and just multiply the arguments. So now we actually have one log on one side and one log on the other. And that means that their arguments must be equal. So we know that x plus 2 times x plus 1 is equal to x times 2x plus 4. And now it's a bit more straightforward how you solve for x. We can multiply x times x to get x squared. X times 1 gives us plus x. 2 times x gives us a plus 2x. And 2 times 1 gives us plus 2. And then on the other side, we have x times 2x, that's 2x squared, and x times 4, which is 4x. And so from here, you can see that we're going to deal with a quadratic. We have some x squared terms. And so what I want to do is get everything to one side, and I want to have a 0 on the other. And the reason why I drew that arrow to the right is because I can see that if I subtract x squared on both sides and get that x squared over to the right-hand side, then I'll be left with a positive x squared. And I like dealing with that, right? So I'd ideally like to get a 0 on the left-hand side and a positive x squared on the other. So x plus 2x, that is a 3x. And so I can subtract 3x on both sides to cancel off all this stuff. And that's going to give me 4x minus 3x, which is a positive x. And then I just subtract 2 on both sides to get my final quadratic here, which is x squared plus x minus 2. And this is something that we can factor quickly and solve for x. So what are two numbers that add to be 1 and multiply to be negative 2? I'll give you a second to think about it. Well, really, you only have the options of 2 and 1 here, so you just got to figure out where to put the negative sign. If you do 2 and negative 1, you found your two numbers. So we can write this quadratic as x plus 2 times x minus 1. And from there, you can see that your solutions are x equals negative 2 and x equals positive 1. So, okay, that should be our answers, right? Well, not quite. There is still something that you need to check for at the end here. And actually, what we're going to check for is going to eliminate one of these solutions. Remember that in a log, you can't have 0 and you can't have a negative number. So you can't have something like the log of 0, and you can't have the log of anything like negative 1, negative 2, negative 3, or any negative number. So what that means is that when we plug these solutions back into our log equation, we better not get log of 0 or log of a negative number anywhere. So let's look. Let's first plug in negative 2 for x. And doing that right away in the first argument here, x plus 2, if you plug in negative 2, you get negative 2 plus 2, and that's 0. So right away you can see that's not going to work. So what that means is that x equals negative 2, it's a false solution, and we call that an extraneous solution. But let's look at x equals 1 now. Can we plug in x equals 1 and get positive arguments all around? Well, if we plug in a 1 for x in x plus 2, you get a positive number, you get 3. You'll get a positive number with x plus 1. You get a positive number with x because you just get 1 there. And then 2 times 1 plus 4 is a positive number. So that works. And x equals 1 is a valid solution. And in this case, it's our only solution. So that's your answer for problem 3. Now moving on to problem 4, what kind of log equation is this? Well, you can see that only one of our terms here has a log. We have other terms in this equation that don't have logs. And so since not all of our terms are logs, what's our goal here? Well, what we want to do is get our log isolated on one side and everything else to the other side. So let's start doing that. To start isolating this natural log, we can subtract 3 on both sides. And that'll get that 3 over to the right-hand side. And that'll leave us with 4 natural log of 2x minus 1 is equal to 11 minus 3, which is 8. Now the only thing left to do to fully isolate that natural log is to get that 4 out of there. And since it's multiplying the natural log, we divide it on both sides. Doing that, we're going to get the natural log of 2x minus 1 is equal to 8 divided by 4, which is 2. And now, since we have that log isolated, we can do that evaluation step. And how do we do that with a natural log? Well, remember, a natural log is the same thing as log base e. So anytime you see ln, you can replace it with log base e. And that will hopefully clear some things up for you as to what you're actually doing. So from here, what we can do is make the e bigger, drag that 2 over, that becomes the power on e, and then the 2x minus 1 goes to the other side. And from here, it's pretty quick to solve for x. First, we add 1 on both sides. And that'll give us that 2x is equal to e squared plus 1. And then all we got to do is divide by 2 on both sides. And that gives us x is equal to e squared plus 1 over 2, which you can just quickly plug into your calculator if your teacher wants that in the form of a decimal. Awesome. So that is problem 4 done. All right, moving on to problem 5. What kind of problem is this one? Well, you can see that, yeah, we do have most of our terms are logged, but the 3 is not. And so again, what is our goal going to be? Our goal is going to be to get 1 log on one side and everything else on the other side. And so you might be able to see the issue that we have here. We have 2 logs on the left-hand side. We just want 1 log, and so we need to combine these logs somehow. And well, these 2 logs are being added. So we can combine them into 1 log. That's a property that we can use. The only thing we have to do is just make sure that we multiply the arguments. So it's going to be x plus 1 times x minus 1 inside this log base 2. And that's going to equal 3. Now, from here, what we could do is just quickly multiply the x plus 1 through to the x minus 1. Doing that, you're going to get an x squared. X times negative 1 is negative x. 1 times x is x. And then 1 times negative 1 is negative 1. And you can see here that negative x plus x is 0, so these 2 go away, and you just have x squared minus 1 left. And if you really think about it real quick, it should make sense to you that what we got is x squared minus 1, because, aren't these the factors for x squared minus 1 if you do difference of perfect squares? And so if you recognize that right away, you could have went a little bit faster. So, yeah. Anyways, now we can evaluate this log. And what I'm going to do is I'm going to make that 2 bigger. The 3 comes over, and it's the power on 2. And the x squared minus 1 goes to the other side. It's the same thing every time. And from here, we solve for x. So 2 cubed is 8. Now we get 8 is equal to x squared minus 1. And from here, there's a few ways that you could solve for x. You see the x squared here, and so I'm assuming you're probably tempted to move that 8 over and get 0 is equal to x squared minus 9. And you can do that. That's completely fine. But another thing that you can do here, if we don't have an x term in our quadratic, what you can do is you can add 1 to both sides, like get everything that's not an x squared to the other side. And then you can just square root both sides. And if you do that, you get x is equal to a plus or minus 3. Remember that when we square root both sides like that, we have to put a plus or minus on one of the sides. So we get that. That looks like it's going to be our solution, but we need to double check. Will, first off, positive 3 work in both of these arguments? Will it give us a positive number each time? Well, x plus 1, if we plug in 3, we get 3 plus 1, that's 4. Okay, that's positive. And in x minus 1, 3 minus 1, that's 2. Okay, that's positive as well. So 3 is definitely a solution that works here. But remember, our other solution is negative 3. So if we plug in negative 3, right away you can see we get negative 3 plus 1 inside the first log. That's a negative number, so no, we can't have that. And so the solution isn't plus or minus 3. X equals 3 is our only solution. X equals negative 3, not so much. So we can say x equals negative 3 is extraneous. All right. Moving on to the last problem for this video. Here, what kind of problem do we have? Well, I see two of our terms are logs, but this 2 is not. And so again, what is our goal? Our goal is to get one log on one side and everything else on the other side. But what's the issue here? We have a log on both sides. So what do? Well, to start that process of only having one log on one side, we have to get all of our logs to the same side. And so what we can do here is subtract the log of x minus 1 on both sides. When we do that, we get the log of x plus 10 minus the log of x minus 1 is equal to 2. And now these cancel off, and great. So now that we have all of our logs to the same side, we can combine them into one log. These logs are being subtracted. So this is a little bit different than what we've been doing. We're still going to combine it all into one log. The only difference is, since they're being subtracted, we're going to divide the arguments this time. And so we get x plus 10 divided by x minus 1. And that is equal to 2. And from here, we can evaluate this log. Now there's one issue here. This log doesn't have a base, does it? I mean, there's nothing here. And remember that when a log doesn't have a base, the base is 10. That's the default base for logs. And so now we have everything that we need to evaluate this. The 10 gets bigger. 2 goes over, it's the power on the 10. And the x plus 10 over x minus 1 goes over to the other side. Now we know that 10 squared, that's 100. So we get 100 is equal to x plus 10 over x minus 1. And now where the heck do we go from here? Because, all our x's are on one side, yeah, but we have this fraction here. So that's kind of stopping us from doing anything. So when we have that fraction, our first goal is to get rid of that fraction. It doesn't matter if the x's wind up on both sides and everything. We can always move those back later. The first goal is to get rid of the fraction. And how do we get rid of that fraction? Well, we can multiply by that denominator on both sides. And yes, if we multiply by that x minus 1 on both sides, it is going to now give us x's on both sides. But that's okay. There's going to be ways to move it back later. So this is kind of messy here, but we can see that we have 100 times x. And then we have 100 times negative 1. And on the other side, we have x plus 10. And from here, you can see it's pretty quick to solve. We can get all our x's to one side by just doing addition or subtraction here. Here, we're just going to subtract x on both sides. And 100 minus x is 99x. Now, we got all our x's to one side, but the negative 100 is still over there. We can't have that. So to move it over to the other side, we add 100. And that gives us a 110 on the other side. So now we divide by 99 on both sides to fully solve for x. And I know the numbers look a little gross, but x equals 110 over 99 can be simplified. Because 99, that's a multiple of 11. That's 11 times 9. And, well, 110, that's 11 times 10. So if we divide this by 11 on top and bottom, we can get that x is equal to 10 over 9. So that's great, we get our solution, but we also need to check this and make sure it's not going to make any of our logs negative in the original problem. Now, our solution is 10 over 9. So let's look here, 10 over 9, that's a little more than 1. So we have something that's a little more than 1 plus 10, that's going to be a positive number. And then we have something that's a little greater than 1 minus 1, that's still going to be positive. So 10 over 9 is going to work here, and so that is our solution to the last problem for this video. And so that is log equations in a nutshell, and if you're feeling pretty good with this, then here's a problem for you to try and answer in the comments. Here we have log of x plus log of x plus 5 is equal to log of 6. So give that a shot, let me know what your answer is in the comments, and if you have any questions on anything we talked about in this video, again, let me know in the comments and I'll try to get back to you when I can. Now remember, I do have that extra video where you and I will go through and solve 12 more of these log equations, so if you're really looking for that extra practice, like if you have a quiz or a test coming up on this kind of stuff, then I highly recommend you check out that video, which I have linked in the description. Lastly, make sure that you guys are subscribed to the YouTube channel. We're getting closer to 100K by the day, and I can't thank you enough for your guys' support. It really helps get through all these videos and everything, because you know, at times it does take a lot of like mental effort to keep going with all this. So anyways, that's gonna do for this video, and I'll see you guys soon.